Here's the answer for the day 4 Bell work. Use the graphing calculator to find the zeros of this function. That means to find all values of x that when you input them, the answer that you get from this formula turns out to be 0. You might recall from Algebra 2 class that when a polynomial goes to the third power, that we expect to get 3 zeros. So there might be 3 real zeros to this. And that's important to keep in mind when we graph on the calculator screen. Because if we don't observe the curve crossing the x-axis in 3 spots, that might mean that the curve would cross, but off the edges of the window. And we would need to zoom out or change the window settings to see more of the curve to see if there are any other answers for x. Let me bring my calculator onto the screen. I pushed the y equals key, and for y1, I've typed in the polynomial function. Now I'm going to push graph. You can see that I don't have my calculator window set to the normal zoom setting that goes from -10 to +10 in all directions. My x-axis is going from a minimum of -3 to a maximum of +10. It wasn't necessary for me to make that change, but it makes the curve larger on the screen for you to see. The zeros of a function are the values of x that cause the function to equal 0. They are the x-intercepts of the graph. There are 3 places on the screen where the curve is crossing the x-axis. It appears to cross right here at x equals 0, right here at x equals 3, and right here at x equals 6. Those are the zeros of the function, and we can write them down. X equals 0, 3, and 6. These were easy to identify from looking at the calculator because they cross the x-axis at integers. What if the curve crossed somewhere between the tick marks? Then we need the calculator to tell us where the x-intercept is. That's done by pressing the second key and then calculate, which is the same button as trace. The choice that you're looking for is choice 2, a 0. We know that there are 3 zeros. The way that you find them is to use the cursor keys to position the blinking cursor on the screen a little bit to the left of where it's crossing the x-axis, pressing enter, then moving the cursor a little bit to the right of where it crosses the x-axis and pressing enter, and then moving the cursor right on top of where it crosses the x-axis and pressing enter. In the bottom left corner of the screen, it now prints the word 0, and it tells you that when x equals 3, the value of y turns out to be 0. That process of keystrokes tells us the exact answer for this x-intercept. We could run through the process again on the calculator to find out this x-intercept, and then again to find out this x-intercept on the right. The directions on the bell work say to copy the screen for one of the zeros. Let's copy the screen that we have right now. The y-axis on my calculator screen runs down over here, and the x-axis goes right across the middle. There are 3 marks going to the left on my screen, and 9 marks to the right. I didn't change the settings on the y-axis, so they have 10 marks. The curve starts here at the bottom of the screen, comes up through the origin, and goes off the top of the screen where it's going to curve back around, kind of like a parabola shape, and then start to come down so that it crosses through 3. It continues on down and goes off the bottom of the screen. It curves around and comes back upwards, crossing through the x-axis at 6, and continues on off the top of the screen. Now the directions on the bell work ask you to copy the screen exactly. So the cursor is located right in this spot. It's kind of blinking, and you can try to show that if you want to. That's not so important. But the word 0 is printed in this position, and the calculator says x equals 3, and kind of right here it says y equals 0. I'm asking you to copy the window exactly so I can see that you're learning how to use the TI-84 calculator to work with functions.